Let us solve this interesting problem from IIT JEE 2009. We have to find the smallest value of k in this quadratic equation so that this equation has real and distinct roots and the values of roots is at least 4. To start, we have to understand the given condition. So one is that the roots are real and distinct, and another one is regarding the values of the roots. So for real and distinct roots, the determinant should be greater than 0. And for the second given information, which is about the value of the smaller root, because for real and distinct root, if I try to plot this, and let's say this is 4, then the graph of this quadratic equation should be like this. The smaller root should be at least 4, or it should be greater than 4. It might be like this. So we have to look for what will be the smaller root. And as we know that the roots are from the standard formula are like this. Which will be the smaller one, plus or minus? Definitely the minus one. So the smaller root should be minus b minus under root d divided by 2a. And this root should be greater than equals to 4. And this will ensure that the second root is definitely greater than 4. So we have these two conditions, and using these two conditions, we have to find k. So let's start. We need d definitely. So we calculate d first. D for this equation is 64 k square minus 64 k square minus k plus 1, which is 64 into k minus 1. So the first condition is d greater than 0, and this means k should be greater than 1. So that is our first condition. And the second one says that minus b, which is minus of minus 8k minus under root 64 k minus 1 divided by 2 should be greater than or equal to 4. After simplification, we have k minus under root k minus 1 greater than or equals to 1. And from this we have to find k. So we will bring k to the left hand side and take the square root on the right hand side. Squaring both the terms, we will have further simplification will give us, and from this equation, this inequality, we have to find k. So we have k should be greater than or equals to 2, or k should be greater than or equals to 1. So this is our second condition. So using these two conditions, we have to find k. And definitely we can see that k greater than or equals to 2 satisfies both these conditions. Hence, the minimum value for k is 2, and 2 is our answer. That was it. If you liked this video, please consider subscribing. I will be posting these kind of solutions almost every day. Wish you good luck.